Hello guys, let's consider an object that is moving horizontal. Okay, let's consider this problem here. A motorist is traveling at 20 meters per second. He's 60 meters from a traffic light when he sees it turn yellow. His reaction time before stepping on the brake is 0.50 seconds. What steady deceleration while braking will bring him to a stop right at the light? Okay, so let's consider the solution. So we can divide this motion into three. Okay, first of all, we consider when the motorist is traveling at 20 meters per second. Then we consider it also when it's traveling at 20 meters per second, just before the reaction. Okay, so we also consider it while the car is slowing down. Okay, so this is A, while the object is moving at 20 meters per second. Then we have section B, just before, the reaction time just before the motorist, apply brakes. Okay, so now from here, when you add B and C, so the distance, of course, will be 60 meters. 60 meters, because the motorist, realized that the traffic light has turned yellow somewhere here, here, but now it took about 0.5 seconds, to react. That is section B. So as you can check under section A, yes, sir, the car is moving at a constant speed. Okay. So also here, the car is moving at a constant speed. So you can see here at C, then the car is slowing down. At C, the car is slowing down. Okay. So now let's check at section B. So we have the displacement there, which is given by the product of the velocity and time, because the car is moving at a constant speed. The car is moving at a constant speed. Okay. Now let's check. V is constant, so it is 20 meters per second. Then the time, as you can see, is 0.5. The time is 0.5. Okay, so it is constant here. You can see the motion diagram here. So the speed is constant. Okay, when we multiply 20 by 0.5, we get 10 meters. So that is the distance here in the section B. Okay, so we can also work out the distance in C. Okay, B plus C, of course, is 60, so which means the distance at C will be B. Okay, let's consider now section B. Okay, at section C, of course, brakes are applied, so the car is slowing down. So you can see this motion diagram here. You can see this motion diagram. Okay, so it shows that the car is slowing down. Okay, let's check. So we're given at C, we're given the initial velocity. Okay, this should be the initial velocity. It should be the initial velocity. So this one is initial velocity. This is initial velocity. Then this one is final velocity. So yeah, when the car has come to stop. So we have the displacement then, which is now 60 minus 10, which is 50. Okay, so we can apply this equation here, which says V final squared equal to V initial squared plus 2A delta, actually this should be delta X, because the object is moving horizontal, so this is delta X. Okay, so then we make A the subject of the formula because we're looking for A. So we can even write this A as AX since it is horizontal acceleration. Okay, so we make A the subject of the formula before we make substitution. So if we make A the subject of the formula, of course, we take this initial velocity to the other side and it becomes negative. Okay, then we divide both sides by 2 delta X, to make A the subject of the formula. Then we make substitution. Okay, the final velocity, of course, is 0. Then the initial velocity is 20 meters per second. Then we square. Okay, so displacement is 50 meters. All right, let's punch our calculator. So the answer is negative 0,2. It is of course negative because the car is slowing down. So which means the acceleration is in the opposite direction. Okay, now remember acceleration is always in the direction of the force that is opposing the motion. So in this case, so we can say it is the frictional force is the one that opposes the motion, the friction between the tires and the surface. So as a result, the car will slow down. So since the frictional force opposes the motion, so also the acceleration is in the opposite direction. Okay, so that is the answer of this problem. So please work out this activity at home. It says a car traveling at 35 meters per second runs out of fuel while traveling up 30 degrees slope. How far up the hill will the car coast before starting to roll back down? So 2.2, a motorist is traveling at 20 meters per second. He's 60 meters from a traffic light when he sees it turn yellow. His reaction time before stepping on the brake is 0.50 seconds. Okay, just like the previous problem that we did together. So 2.2.1, how far is the motorist from the intersection when he begins to apply the brakes? Okay, so 2.2.2, calculate the acceleration that will bring the car to stop at the edge of the pedestrian crossing, which is 3 meters from the intersection. Then you need to assume that the reaction time remains the same as 0.50 seconds. Okay, 2.3. A speed skater moving on to the left across frictionless ice at 8.0 meters per second hits a 5.0 meter wide patch of rough ice. She slows steadily, then continues at 6.0 meters per second. What is her acceleration on the rough ice? So 2.4, when the light turns green, the bicyclist starts forward with an acceleration of 1.5 meters per second. So 2.4.1, draw a pictorial representation for the following problem. Do not solve the problem. 2.4.2, how far must she travel to reach a speed of 7.5 meters per second? Okay, that is the end of the lesson. Thank you for taking part of the lesson. All the best. Thank you. Bye-bye.